So today we have Atcoder beginner contest. The contest is just started. Let's see it. So just 10 seconds remain to start. So I am going to record myself. I will try to explain as much as possible while recording, while solving. Whiteboard. So Atcoder beginner contest today we have. So I will try to explain as much as possible. So this is the first problem we have. So this is the second problem we have. So you can say this is the second problem we have. This is the second problem we have. This is the third one, the fourth one, and the fifth one. So let's read the problem. First problem we have Atcoder. In Atcoder, the top 10 rated players username are displayed with a gold crown. Okay, and the top 10 rated player and the top rated player's username is displayed with a platinum crown. Okay, so at the start of this contest, the usernames and rating of the top 10 rated player in the algorithm category are as follows. So you are given a string, given the username s of one of these player, print that player's rating. अच्छा, players का rating. So let's copy all these. So they will give one of the username and they are asking you to find uh, find the they are asking you to find the, they will give you one of the name and ask you the username. So how will you deal with the problem? So very simple. I am just, they are basically giving you the input. So very common sense. What I will do, I will put I will put, I will not put input. Let's say has include bit slice std dot h, has include bit slice std dot h. Okay, then using namespace std, using namespace std, then after we have a int main, and what we can do here, I am copying these things. Okay, let's put curly bracket, let's put curly bracket like this, and then have a comma, then again we have a curly bracket. So how can we put curly bracket like this, then curly bracket, then curly bracket, then put a comma, and then a curly bracket, comma, curly bracket, then again curly bracket, comma, curly bracket, curly bracket, Okay, then again we have a comma, then we have a curly bracket, then we have a curly bracket, then we have a comma. यार बहुत करना पड़ रहा है. Don't be panic. So we can do the things like this. Okay, and then put comma in mid also. Okay, तो ये रहा. हम क्या लिख सकते हैं? We can write like that, vector of pair of a string comma int v is equal to, so this will become a vector of pair of int, and after that we will have a string s, so take it as an input, c in s, and then we can run a loop for int I equal to 0, I less than v dot size I plus plus. If v of I dot first is equal to s, so c dot v of I dot second and indel, and then break, and then return 0. I think this logic will work. String comma int. The compilation has been started. V dot size. अच्छा, ये स्ट्रिंग नहीं है तो डबल डॉट के अंदर में डालना पड़ेगा सबको. अरे यार, उमनिक. तो अगर हम इसको अब रन कराते हैं तो रिस्ट छूट गया. So it's working, so now we can submit it. So it took a lot of time. I I used to manually remember and write the name. It will be better. It took 10 minutes. So we can move to our next question. You are given positive integer and print a string of length n plus 1, s0, s1, sn, defined as follows. Okay, so for each I बराबर 0, 1, 2 and if there is a divisor j of n that is between 1 and 9 inclusive j of n and I is multiple of n by j, I is multiple of n by j, then si is the digit corresponding to a smallest such j. If no such j exists, si will be thus one of the 1 to 9. If no such j exists, then si is minus. So basically you are given a positive integer and print a string of n plus 1 length. Okay, for I बराबर 0 to n, ठीक है. If there is a divisor j of n that is between 1 and 9, 1 and 9. So if there is a number which can divide n which is present in between 1 and 9 inclusive, and I is a multiple of n by j, divisor of I is a multiple of j, then si is the digit corresponding to the smallest such j. Acha, if no such, acha, very simple. We have to iterate over I, and each time we will iterate over j from 1 to 9 and check that if n by j, if I is a multiple of n by j, so we will see one of the divisor of j of n and I is multiple of n by j. So n by j is the divisor of I, so then si is the digit corresponding to such j. So we can simply again we can write has include bits slice stdc plus plus dot h, then we can write using name space std, then we have a int main, and in that we will take an integer n as input c in n. Okay, then what I will do, I will iterate over I equal to 0, I less than equal to n, and I plus plus. Then I will iterate over j for int j equal to 1, j less than equal to 9, and j plus plus. Okay, if n modulo j is equal to 0, and inside it check that uh, n by j I modulo I is a multiple of n by j is equal to 0. That means j is going to be one of the character. So let's have a string answer. So in that case, answer dot pushback j plus character 0. Very simple. And here let's have a flag equal to 1. So let's have a flag variable before entering in the j loop and initialize it with 0. So after emerging from this j loop, check if flag, so flag is equal to, if flag is 1, flag is equal to 0. In that case there is no j which you can use for the ith character, then we have to use a negative sign that is given. So in that case answer dot push back, there is a character minus, very simple. So after doing all these things we have to simply see out our answer. So I am just outputting my answer string, and then we have to return 0 because we are inside the int range. So let's see it working or not. So what it is giving, so it has a character 177777. So what it is going here, I is less than equal to n, int val equal to, so n by j, very simple. So we can use here val. Okay, so basically we have to break here. Okay, that's why it's giving error. So you can see it's working now. So we can submit our second problem code, and obviously it will be, it should be correct. Let's see what happens. So we have done this question in around 7 minutes. First question took a lot of time. Let's move to the third question. We have, there is a 3x3 grid with numbers between 1 to 9. So we have a 3x3 grid, and in that grid the numbers are ranging from 1 to 9 inclusive, written in each square. The square at the ith row from the top and jth row from the jth column from the left contains the number Cij. Okay, okay, the same number may be written in different square, but not in three consecutive cells, vertically, horizontally, or diagonally. More precisely, it is guaranteed that Cij satisfy all of the following condition does not hold. Acha, any of the row is not going to equal, any of the column is not going to equal, any of the diagonal is not going to equal, and Takahashi will see the numbers written in each cell in random order. Okay, so he will get this appointed where there is a line, vertical, horizontal, or diagonal, that satisfy the following condition. So Takahashi will see the number written in each cell in a random order. He will get this pointed when there is a line, vertical, horizontal, or diagonal, that satisfy the following condition. The first two square he sees contain the same number, but the last square contains a different number. Find the probability that Takahashi sees the number in all the square without getting disappointed. So हमको probability निकालना है कि find the probability that Takahashi sees the number in all the squares without getting disappointed. तो probability क्या होगा? ये बात ये है कि first two square he sees contain the same number, but the last square contains a different number. So we have 3 rows, 3 columns, and 2 diagonal. So we can explore each row in two ways, each column in 2 ways. So 3 rows, the exploration number of exploring way is 6, and 3 column, the number of exploring way is 6, and 2 diagonals, the number of exploring way is 4. So 6 plus 6 plus 4, it's 16. So there are 16 ways of exploration. In those 16 ways, how many ways you can say is valid according to Takahashi के हिसाब से जो है उस सारे 16 वेज में से कितने वेज जो है एक डिसअपॉइंट नहीं करता है ताकाहाशी को. So how can we do that? So ठीक है, हर एक रोज में हमको आइटरेट करना पड़ेगा, हर एक कॉलम में डायगोनल. So let's count the number of ways in which he is not going to disappoint. So what find the probability that Takahashi sees the number in all the squares without getting disappointed. So let's say x number of ways in which Takahashi will not get disappointed. So x by 16 will be the answer. So that's it, we have the choices we have. So how can we do that? Simply we have to take the input 3 cross 3 grid. So very simple. Haj include bit slice stdc plus dot h. Then we have using namespace std, and then we have a int main, then we have a int grid. So I have made a 3 cross 3 grid. Then I will take input for int I equal to 0, I less than 3, I plus plus, and same for int j equal to 0, j less than, and j plus plus. Okay, so these are the two things we have. So see in grid of ij, let's take this input, and after that we can iterate our row and we can iterate our column. So let's think about diagonal. Let's count the ways in which diagonal can be the point of doubt. So diagonal can be a point of doubt. So we can think that in a very simple manner. If grid of 0 0 is equal to grid of 1 1, in that case count will be incremented by 1. In the similar manner, if grid of 1 1 is equal to grid of 2 and 2, then also this is one of the way in which Takahashi is not going to disappoint. Let's talk about the I have covered the one diagonal. Let's talk about the another diagonal. So if grid of 2 0 is equal to grid of 0 2, grid of 0 2 is equal to grid of 1 1, then also this is one of the way in which Takahashi is not going to disappoint. So increment by 1, and again we have a case that grid of 1 1 is equal to grid of we can move towards the second row and 0th element. So this is also one of the way in which Takahashi is not going to disappoint. Let's talk about the row. For int equal to 0, I less than 3, I plus plus. So if I बराबर for int j बराबर 1, j less than 3 और j plus plus, if uh, grid of I j is equal to grid of I minus I or j minus 1, I or j minus 1. So it is going to increment the count value by 1. Okay, so I have do the same thing for the column. We can do the same thing for the column. For j equal to 0, j less than 3, and j plus plus, and for int I equal to 1, I less than 3, I plus plus. So let's write a line. If grid of I j is equal to grid of I minus 1 j, so you are in the jth column, so then increment the count by 1. So in this way we can count the so we can count the number of ways in which Takahashi is not going to disappoint. So what we can do, let's have a double of lower is equal to 16.0. okay, then double of upper is equal to nothing but count. So C out upper by lower in del. So it is going to work here. So what they are telling you, C++ bit slice std++ dot h. Now it will work. So where I have used n, somewhere I have used n, it should be 3. So 0.625. C ought L C ought count. One by 16. How much they have counted? Two by 3. Does not hold. Takahashi sees the number in all the square without getting disappointed. Print one line containing the probability that the Takahashi is बात का क्या प्रोबेबिलिटी है कि ताकाहाशी जो के पास बहुत सारा तरीका है इस ग्रिड के नंबर को देखने का. Is not going to disappoint. So there are many ways in which Takahashi can look up in the grid. There are many ways. We will get disappointed when there is a line that satisfies the following. The first two squares he sees contain the same number, but last square contains a different number. So what is the probability that Takahashi sees the number in all square without getting disappointed? Takahashi जो है सारे स्क्वायर का नंबर भी देख ले विदाउट गेटिंग डिसअपॉइंटेड। बहुत सारा तरीका होगा देखने का जिसमें वो बहुत सारा तरीका हो सकता है देखने का। रैंडम ऑर्डर में नंबर को देखती है ताकाहाशी। पहले कोई पहले कोई पहले कोई पहले कोई पहले किसी को पहले बाद में किसी को। एक तरीका है रैंडम ऑर्डर में देखती है। तो there are many ways in which he can see the number. I think this is a little tricky question, so we will solve this question onward. And basically we have to count the ways randomly. He can pick one of the ways. To the power 13, there are 9 ways. I have to explore all the ways. So what is the probability that Takahashi sees the number in all square without getting disappointed? Number of ways to see and number of ways to get disappointed. Number of ways to see and number of ways to get disappointed. That number of ways to get disappointed. What is the fourth question we have? This. What is the fifth question we have? First stop. Let's say it is I think this is a graph question, so let's solve it. Takahashi is initially at his house and is about to visit Aoki's house. Takahashi is initially at his house and he is about to visit Aoki's house. So there are n bus stops numbered 1 to n without 1 to n between the two houses. So there are n bus stops numbered from 1 to n between the two horses. Takahashi can move between them in following ways. So he can move between the bus stop in the following ways. He can walk from his house to the bus stop 1 in x unit of time. So he can first start his journey from the bus stop 1 in x unit of time. Okay, for each I बराबर 1 to n minus 1, the bus departs from bus stop I at each time, that is a multiple of pi. For each I from 1 to n minus 1, the bus stop departs from the bus stop I at each time, that is a multiple of pi. So pi is the integer you have given. The bus will depart from every second. There will be a bus to a bus stop pi, multiple of pi, and by taking this bus he can get to bus stop I plus 1. By taking this bus he can get to a bus departs from bus stop I at each time, that is a multiple of pi. So there is some number of buses now and bus stops, and by taking this bus he can get to bus stop I plus 1. So he will take the pi bus and reach the bus stop I plus 1 in ti unit of time. Here the constraint guarantee that pi is less than equal to 8. So there is only 8 buses we have. 8 numbers we have. Pi value is will be from 1 to 8. Okay. So Takahashi can walk from bus stop n to Aoki house in n unit of time. So Takahashi can walk from bus stop n. So he can start his walk from bus stop n to Aoki house in y unit of time. So once the Takahashi will reach the nth bus stop, he will move to the Aoki house in y unit of time. So we have Q queries. Find the earliest time that Takahashi can arrive at Aoki house when he leaves his house at time qi. Find the earliest time. Okay. At Takahashi can arrive at Aoki's house when he leaves his house at time qi. (34) sample output 34. So 13 12 13 1 21 134. Oh. 22 22 add 21 into 48. So let's solve the first question, third question first. So basically we have uh, queries. Basically we can start from the any node, go to any node. Okay, so this is the things we have. This is the thing we have. So is your way of disappointing or not? So I will try to write a recursive solution for this problem. So we have a grid. So we want to count it. Uh, um, so let's have a function which is call that function, and it is going to count with the uh, so we can start from any node. Let's move to a D question. Takahashi is displaying a sentence with n words in a window. Takahashi is displaying a sentence with n words in a window. All words have the same height and the width of the ith word is alive. Takahashi is displaying a sentence with n words in a window. All words have the same height and width of the ith word is alive. Width of the ith word is alive, and all words have the same height. So the words are displayed in the window separated by a space of width 1. More precisely, when a sentence is displayed in a window of width w, the following conditions are satisfied. Window of width w. The sentence is divided into several lines. सही बात है. The first word is displayed at the beginning of the top line. The ith word is displayed either with a gap of 1. Ith word is displayed either with a gap of 1 after the I minus 1th word, or at the beginning of the line below the line containing the I minus 1th word. It will not ith word. It will not be displayed anywhere else. अच्छा. So ith word is displayed either with a gap of 1 after the I minus 1th word, or at the beginning of the line below the line containing the I minus 1th word. It will not be displayed anywhere else. The width of the each line does not exceed w. So the width of the each line does not exceed w. Here the width of a line refers to the distance from the left end of the leftmost word to the right end of the rightmost word. The width of the each line does not exceed w. Here the width of a line refers to the distance from the left end of the leftmost word when Takahashi displayed the sentence in the window. The sentence fit into m or fewer lines. Find the minimum possible width of the window. So m or fewer lines. minimum possible width of the window, so we have to minimize the width of the window, so we can use binary search for this. So we have n words, so we have to we will use binary search. As we can see, so when the width of the window is 26, you can fit the given sentence into 3 lines as follows. First will be n m, and then we have an input n m. So simply we can use binary search here. Has include its slice stdc dot h. Then we have using name space std. Then we have int main. Then we have two integer int n comma m. Let's input these integers. Then we have a array. Okay, then we have a vector of int arr of size n, in which we will input our for int I equal to 0, I less than n, and I plus plus. Then cin, then we will input our ith, the length of the ith string arr I. Okay, so this is the length. So now we can have a binary search. So let's say the width can vary from s equal to 0 to 1e7, e equal to 1e7, e equal to 1e7. So let's have a binary search in this range. S is less than equal to a. Then we have a int mid equal to s plus e minus s by 2. Then if checker function, let's call a function check and tell him that if the width is equal to mid and we have a given arr and the size is n, can you tell me is it possible with the width mid? And we will use m number of lines and represent the whole string. Can it possible? If it is going to tell you yes, correct, then we have a int answer is equal to, let's say, int max. Then we want to minimize that, so answer equal to minimum of answer comma what, the mid value. And after that, what we can do, after that we will search in the lower value, we'll search for the lower value. So I am decrementing the e to mid minus 1, and then if this is not the case, then we will search in the higher range like this. So this is the thing we have. After this, we will simply see out our answer and indel from there, and we will return answer. So let's see the constraint we have given. So the constraint is that li will be 10 to the power 9, and so why not we will do the things in ll. So has defined ll and long. So let's make it long ll. Okay, let's make it ll. So do the all the stuffs in ll, so that there will be no error in that case. So let's make it 118. So what the things we have given in the question? 2 into 10 to the power 15. So let's make it 10 to the power 17, and let's have it 10 to the power 16. Then we have a ll. very these things we can do very simply. Return 0. Okay, okay, these are the things we have. Then we will simply we have to write a checker function bool check. We have first input is int width, then we have second input is arr, comma vector of int arr. Then the third input I have is nothing but an integer n, and the fourth input I have a integer m. So very simple. Let's count the number of lines you will need. Okay, so I am counting that with a long. Okay, so long equal to long len equal to 0. Very simple things we have. Okay, now we will iterate over the whole int I equal to 0, I less than n, and I plus plus. Okay, let's say after iterating whole we will calculate len. If len is less than equal to m, in that case you can use the width equal to w, to represent the whole sentence in len number of lines, which is less than m. That's why it's possible. In that case we will return true, otherwise if this is not the case, return false. Okay, so these are the things. Let's see one more thing in the question, that how the words will be arranged. Okay, like that we have to do the things. Width of the each line does not exceed w. Width of the each line and not. Okay, very simple. For doing that, we will simply iterate over. Let's say currently you are in the len number of lines. Len in which line you are currently working, len, and how many words you have inserted in this len. Let's say 0. How many characters you have inserted. So after adding this line, if let's say if arr of I is greater than w, in that case we have to return false, simply because there is a word in the given sentence which has character greater than w. In that case we can't represent in a line having width w. Very simple. And the second case is, let's say l1 plus equal to arri. Okay, so arri, very simple, arri. So if l1 is greater than w, l1 is greater than w, in that case very simple, we have to increase the len by 1, and also l1 is equal to arri. Very simple things we will do. Okay, very simple. Else l1 is, else if l1 बराबर w, what will we will do in that case कि l1 is equal to w, l1 is equal to w. In that case also increment the len value by 1, and l1 is equal to 0. Else L1 is greater than W. Else if L1 is equal to W minus 1, in that case, also increment the len value by 1 and L1 is equal to 0 and go to the next line. Okay, and if this is not the case, in that case, if this is not the case, in that case, don't increment, insert a space. Okay, insert the space. So for inserting a space, we have to increment the len by 1. Very simple. Okay, very simple. It's obvious. So here is one more thing we have. So uh, if I is equal to n minus 1 and len is not equal to 0, len is not equal to 0, in that case, len is not equal to 0, in that case, L1 plus equal to ARRI, L1 len plus plus len plus plus len plus, here L1 plus plus. So if len is not equal to 0, nahi, L1 is not equal to 0, L1 is counting the character now. Okay, L1 is not equal to 0, in that case you are at the, so what we have to do, we have to simply increment the len value by 1. This is the thing we have to do. If I is equal to n minus 1 and L1 is not equal to 0. Okay, so this is the thing we have. So will it work? So let's make it LL, vector of LL. Let's make it LL, make it LL, make it LL. I think it should work. Let's see it works or not. So it's working, it worked. So we can submit the solution for this problem. So let's submit it. Oh, so it's giving wrong. On 8 test cases it is giving wrong. So where it is giving wrong. So len is equal to 0. There is one more thing we have. 5 character you have inserted. So width is w. L1 plus equal to AR and I. Very good. L1 is equal to W. क्या करना है भाई? यही ना करना है कि पहला को रखें और विड्थ W नहीं यार, W कहीं चेक कर रहे हैं क्या? पहला आर्गुमेंट मिड है, फिर ARR है, फिर N है, फिर M है. Hasn't worked. Turn false. L1 plus equal to ARR I. L1 is greater than W. So len plus plus L1 equal to ARR I. L1 is equal to W. उस केस में क्या होगा? L1 is equal to W. So len plus plus minimum width. Yeah, you guys should try. So it at last it worked. So we can, so we have same logic worked at last. Why it was not working at that time? So in the first query, Takahashi can move as follows to arrive at Aoki house at 34. He leaves his house at 13, walk from his house and arrive at bus stop 1 at 15, and take the bus departing from the bus stop 1 at time 15 and arrive at bus stop 2 at time 19. Okay, take the bus departing from the bus stop 2 at time 24 and arrives at bus stop 3 at the time 30. Okay, bus stop 3 at 30 and arrives at bus stop 4 at 31, and walk from the bus stop 4 and arrive at 34. For the second query, Takahashi can move as follows and arrive at Aoki house at 22. He leaves the house at 0. He walk, arrive at bus stop 1 at time 2. Okay, 7, time 2 to 7, 9. So, and arrives at bus stop 2 at time 19 in just 4 seconds. Just 4 seconds. So let's read the problem statement correctly. So there are n bus stops numbered from 1 to n between the two houses, and Takahashi can move between them in the following ways. He can walk from his house to bus stop 1 in x unit of time. X unit of time. For each 1 to n minus 1, a bus departs from the bus stop I at each time. That is multiple of pi. That is multiple of pi. So if the time is multiple of pi, then the bus will start from there at a multiple of pi. By taking this bus, he can get to bus stop I plus 1 in pi units of time. So your query qi is 0 to 10 to the power 9. So we have some number of buses now. We should first attempt third question. We should attempt, I think. It may be the case that we can do it. He will not get disappointed. function you add at the ind step. And let's say you haven't pushed any element, read any element in the grid, and then you have a main element to read, and you have a mask 0 that which you have read. Okay, so after that what you will do, you will start int f of int ind comma int mask comma vector of int vector of int grid vector of int grid 3 comma vector of int 3. That's what you have made. So let's have a vector of int grid vector of int grid. Okay, then what you can do, you can simply do one thing, that first check that the grid you are currently in. So let's make a vector of int grid 1 3 comma vector of int 3. Okay, for int I equal to 0, I less than 9, I plus plus. If one left shift I and mask is not equal to 0, then this element we have read. So if we have read, so then we have, so 0 to 9, how we can decode it? 0 to 9, I plus j, int I equal to 0, I less than 3, I plus plus. For int j equal to 0, j less than 3, or j plus plus. So we have a int val equal to I into 3 plus j. Okay, so let's put it val. Okay, and if this is the case, let's put it -1. So -1, put it -1. And let's have a one more thing, that we have to do one more thing. Grid 1 of ij, grid 1 of ij equal to grid of ij. Okay, and after that what we will do, we will simply do one thing, that we will check that so we will check these lines, write these lines. Let's put it grid 1, let's also put it grid 1, not put, make it grid 1, don't make it grid 1, let's make it grid 1 and make it grid, and let's make it grid, and let's make it grid 1. Very simple. Okay, and grid 0 0 is not equal to -1, and grid 1 1 is not equal to -1. Same goes for here. Let's pick these lines and copy. So it's not 0 0, it's 1 1 and 2 2. So make it 2 2 2 2. Okay, again copy this line, control V, 1 1, and we have to put 0 2. Okay, 1 1 and 2 0 we have to put, 2 0 we have to put. Okay, very simple things we have. And we have to put that line ij minus 1, ij and ij minus 1. Okay, these are the things we have. Okay, same goes for this. Control V, ij I minus 1j, I minus 1, and then we have another variable j. So if this count barabar 0, so in how many ways you will get disappointed? The ways you can, if this count value is not 0, then you have disappointed, already you have disappointed, so you will go disappointed. So this is the way of disappointed. So you have disappointed, already you have disappointed in this path. Okay, so let's have a for loop. For int I equal to 0, I less than 9, I plus plus, if one left shift I and mask is not equal to 0, that means we should take this element, and so run this function f ind plus 1 and mask or one left shift I. Then we have a grid 1. Let's say we have another variable. Let's make a count, int count equal to 0. So let's have another variable. Let's have a int val. While calling the function, this function f, we have to give the grid. Then we have a, let's say that val value is 0. So maximum of val comma count. Okay, minimum of count comma 1. Likewise we can think of, so this is the thing we have. So int answer equal to 0, answer plus equal to this much, answer plus equal to this much, and we have to return answer. So if ind equal to, here we have to check if ind is equal to 9. So if val barabar 0, if val is equal to 0, then return 0. There is no disappointment. In this case, return, there is a disappointment. It is a disappointment to return one. So there are how many ways? 9 ways. After that 8 ways, 9, 8, 7, 9 factorial. So 9 factorial is around that. Very simple. So there is 9 factorial ways. In 9 factorial ways there are some ways uh, 9 factorial ways. So if we erase all these things, let's say once C odd count. If Takahashi is seeing C31, C21, he will get disappointed.